Afternoon and welcome back to the second milestone from the Cappy Express group about the ABET project. In this case, we are going to look forward into the design, process and validation. So first of all, we need to understand that, as mentioned the previous week, the most important thing in the project was, and the most important problematic was about the leader. So the first thing that we're going to tackle in this conversation will be the leader process or the perception system. This perception system will have some key considerations that needed to be done. For example, we're using the leader as mentioned the week before, but we're also using ROS 2 to integrate the leader and to process everything into the Raspberry. As we can see on the right side of the page, we can see that we have Raspberry, ESP32 and computer, as we are going to have these three main components in where the perception system will function. The main purpose of the Raspberry is to be the processor of all of this, to have Linux Ubuntu 24.4 server, to have ROS DOS with several libraries that you can see there, to have the camera connected with some code in there, in the processor. For what? For deciding what's the optimal next step, both for the future track and also for the identification of the box. After that, we have the ESP32 that is just in charge of the motion. So it will constantly communicate with the Raspberry Pi and it will exchange information on knowing how the motor should be activated. If the robot should go faster, slower, it should go left, right, or backwards. That data that was processed on the Raspberry will be sent to the ESP32 for knowing that. Finally, the computer is just working for the moment as a visualizer, as a place where we can see the data from the Raspberry, as Raspberry needs an interface so we can see what we're doing on that processor. So we're using for this moment a computer for that. After that, for example in here, we can see a little code. This is a simple code just for starting using the leader. This is just the first steps of leader perception and everything. And it is important to know that leader provides a huge amount of data, and that it is really important to be conscious about that, and that probably there will be room for optimization as the processor is just enough for this process. A little bit more of requirements and the Raspberry Pi won't be enough to process all the data that the leader gives. Then we also have on the other side the gripper that was also discussed on the previous week. We can see in a red box like the future box of the project, and we can see the design of the gripper as proposed in the last week. We can see those two arms that are holding onto the future box, and then we can continue seeing how the mechanism was designed. We can see these two gears. Here below this gear we can see a servo motor, and with the movement of these gears the close of the gripper will open or close to hold on to the box. So that is also important. Then we can see the lifting system. We can see a side view of the system, and we can see this racking here that will be used for the lifting of the system, which can be seen in this photo here with a gear and the rack. Also, it is important to consider these two main components that are going to help the gripper to hold on to the main structure that was provided to the project. And with all of that, it is possible to see a brief overview of what is the objective of this project. What is the goal? Finally, we can see a photo of this implemented and several components that are were considered for this stage. We can see the mobile robot kit that was provided, the robot gripper that was designed, the gripper elevation system that was also designed, Raspberry Pi 5 that is below the case, LiPo battery, the magnetic sensors that are just here, the camera that I didn't mention before but will be positioned in this place, ultrasonic sensor that will be below for detecting if the box is close enough so the claws of the gripper can close. Then we have the ESP32 that is also below here, electronic board that is also below here, the PLC Siemens and everything regarding the PLC and the routers are outside from the robot because they are for the future interface that we are going to implement. We have the servo motors, two servo motors, one for this gear system and one for the other gear system. We have the bridges L298N bridge that are for controlling the motors. Boxes, obviously, as we are going to lift boxes and move them to another place. The grid for the boxes and the shelf for the boxes that will be future planned for the project as the starting and finishing point of the track. And that will be all. Thank you so much.